So today we're going to talk about a theorem called the rational root theorem, and this is something we rely on if I ask you to do some factoring, but I don't give you a hint, and we'll see what that looks like in a minute. So as long as you have a polynomial where all you see are whole numbers, no fractions, then every possible x-intercept or every possible zero has the form p over q. So there's two new letters for you. We have not talked about p's and q's, and those letters do pop up in this theorem. So p represents a factor of the constant term of your polynomial, and q is a factor of your leading coefficient. So we're going to make a list of all of our p's, and then we're going to make a list of all our q's, and then we're going to write them as fractions, and that list of fractions that we compose are all possible solutions. So we would have to check them using synthetic division to see if they actually work. So we'll start off with an example of a cubic polynomial. You can absolutely try grouping and seeing if factoring by grouping works. It's not going to in this case. So the only factoring trick we have is using synthetic division, but usually I give you a hint for that. So I'll say, hey, this number goes in, but I did not do that here. So the question is, what do you do if I don't give you a hint? You're not out of options. It's just going to be less convenient. So if you identify the constant term, it's going to be 20. A constant is the number with no variable. So I want to list all the factors of 20, and we call those our p's. So you have 1 and -1, because you have to remember you can divide 20 by -1 as well. You can divide 20 by positive or -20. You can do positive or -2 and positive or -10. You could have 4 and 5. And those would be all your possible p-values, so we're just listing factors of 20. Then you want to list the factors of your leading coefficient. So if you look at this problem, the leading coefficient is 1. There's only two factors of 1, and it's 1 and -1, so you don't have a big q list. So then what you get to do is you get to take each of your p's and put them over each of your q's. So if we put 1 over 1, we get 1. If we put 2 over 1, we get 2. 4 over 1, we get 4, and etc. So we could get 5, 20, or 10. So this is your list of possible zeros. So these are your possible hints right here. All right, one of these, at least one of these, has to work in order to factor this problem. So this is the annoying part. Once you make your p's and q's and then you use them to make your possible x-intercepts, now you got to start guessing. So I'm just going to see if 1 works when you use synthetic division. So I'm going to write down my 1, -8, 11, 20, and I'm going to synthetically divide by 1. Now if this works, remember we always want to get a remainder of 0. So if I don't get a remainder of 0, 1 doesn't work. I'm going to have to guess a different number. So if I were to use 1, I'm going to get 1, -7, and 4. 4 times 1 is not going to make a remainder of 0, so 1 failed. So then I just move on to another number. Maybe -1 will work. Maybe I'll get lucky. So we're going to set up our synthetic division again, and we're going to really hope we get a remainder of 0. So if we run through that real quick, you'll find that you actually do get a remainder of 0, which is awesome. So part of the mystery is solved. So what I'm going to do is I'm going to take my synthetic division that worked and I'm going to convert it to factored form. So -1 means you have x plus 1, and then all of these guys would drop a power. So you would begin with x squared and then x, and then 20 is now your constant. And the good news is this is a quadratic, and we know how to factor the quadratic, so we can use that x method. So I know that this is going to factor into x minus 4 and x minus 5. You just don't want to forget the task said to solve. So I need to know what are all the possible answers for x. So once you have it factored, you can go ahead and solve it. So you're going to get -1, 4, and 5. So all of these would have worked. So if you would have guessed 4 instead of -1, you would have found that 4 worked, and when you set it up, you would have gotten the -1 and the 5 as your other two answers. So as long as you can just guess one of these from your list, you can get through the problem. Number 2 is going to be a little more complicated. So if you notice, this is a quartic function. So you have to think every time you do a round of synthetic, you basically knock this down a power. If we always want to get to quadratic world, it's going to take 2 rounds of synthetic to go from a quartic to a quadratic. So we're actually going to have to guess 2 numbers that work this time. Again, I didn't give you a hint, so you're going to have to start by making a list of your p's and then making a list of your q's. So factors of 12 would include 1, 2, 3, 4, 6, and 12. Then I need to list factors of 10, which would be 1, 2, 5, and 10. And then we have to list all the combinations of our p's over our q's. So what I would do is just take, for instance, if p is 1, I would put this over all my different q's. So I have 1 over 1, 1 over 2, 1 over 5, and 1 over 10. So that takes care of if p is 1. So what if p is 2? Well, then you'll have 2 over 1. 2 over 2, but that's just 1, and I already have 1, so I'm not going to write 2 over 2. 2 over 5, and 2 over 10, but 2 over 10 is 1/5, and I already have that listed, so I'm not going to write 2 over 10, and that takes care of the 2's. Now I have to do the 3's. So we have 3, we have 3 over 2, 3 over 5, 3 over 10. Then we have to do the 4's, so we have 4 over 1. 4 over 2 is just 2, and we already have that. 4 over 5. 4 over 10, but that's 2/5, and I already have that, so I'm not going to write 4/10. Then we have to do 6 over 1, 6 over 2, which is 3, 6 over 5, and 6 over 10, which is really just 3/5. I already have that. So now we move to the 12s. 12 over 1, 12 over 2, which is 6, and we already have that. So 12 over 5, 12 over 10, which is the same as 6/5, and I already have that. So these are all my possible factors. These are all your possible hints. If you count them up, there's 32 possible factors that you would have to check. At most, 4 of them will work. So maybe you'll get lucky and guess one of the potential 4 that work. So what I typically do in class is I have students work in groups of 4, and every student picks a row. So maybe student number 1 will say, I'll check all these factors. Student number 2 says, I'll check these factors. So they kind of work as a team and divvy up the workload. You only need to find 2 numbers that work, then you can stop guessing. So what my kids in the previous year found was -1/2 worked. So they would set up their synthetic division, check -1/2, and they're going to find that they get a remainder of 0. So they're happy with that. So we go from a quartic to a cubic. So we have to guess again. So this is kind of our new problem. So we still have to factor this cubic down. I can pull out a 2 from here and distribute it into the first parenthesis. That makes these numbers a little smaller to work with. And the good news is, if you're trying to use p's and q's, your p's would have to be factors of 12 and your q's would have to be factors of 5. So in other words, since we have q's on the bottom, any bottom that's not a factor of 5 can be eliminated. So we can't have 1/2. 2 doesn't go into 5. So 2 can't be a q value for the next round. 10's not a factor of 5. It's a multiple, but it's not a factor of 5. So I can get rid of 3/2 and 3/10. So everything that's left, the denominator is a factor of 5. And so we'd have to do another round of synthetic and figure out, okay, what works? And what my kids last year found was, oh, 3/5 actually does work. So they went through their synthetic and they got a remainder of 0. And then we're going to convert this into factored form. I don't want to forget I had a 2x plus 1. This becomes x minus 3/5, and this becomes 5, -5, and -20, and now we're down to a quadratic. We do have a GCF of 5, so we can pull that out and apply it to this parenthesis, which makes the fraction go away. And this is my new problem. So this is what it looks like factored. So if I were to continue that, remember, they actually want you to solve this equation. They want you to figure out all the answers for x. Now, if I try to use the x method to factor this polynomial, it's not going to work. There's nothing that makes -4 that makes -1, but that's okay. Because keep in mind, what you're doing is you're basically setting each parenthesis equal to 0, and you're solving for x. So the first parenthesis will get -1/2, the second one is 3/5, and we knew that because we already guessed those numbers work. What I need to do is solve this equation, so I have to use a different method. If I can't use factoring, I could use, say, the quadratic formula. So if we put these numbers into the quadratic formula, we're going to get 1 plus or minus root 17 over 2. That cannot be reduced, so those are my other two answers. The one using the plus and the one using the minus. So I get my 4 answers. I would have never guessed this one, but these ones I could have guessed.